Consuelo Mathletes. Today we are going to start talking about equations. Up until this point, we've been talking about things that are not equations. Today we're going to start talking about equations. First of all, what does it mean to solve an equation? So I'm going to kind of scribble some stuff on this page. Don't bother writing anything down yet. But what does it mean to solve an equation? Well, some people say it satisfies, your answer satisfies the equation. I don't know what satisfies means. Like, does it make it happy or what? What it is when you solve an equation is you're making a statement. You're making an equation. You're making the statement true. Okay, but that's not good enough. Why? Okay, take this for example. You have x plus 3 equals 7, so you subtract 3 from both sides and you get x equals 4. Okay, if I substitute 4 in for the variable, does it make the statement true? Yes, good. So that's your solution, okay? But what if I say this? X squared equals 16. Okay? Now, let's say you take the square root of both sides, and that's why I don't want you to write this down, because this is something a little beyond where we're going to go right now, but I just kind of want to give you an idea of what I'm talking about. Okay, let's take the square root of 16 and the square root of the x squared. So some people say x equals 4. Okay. Well, does 4 make the original statement true? Yes, it does. But 4 isn't the answer. Why not? Because it's not everything that makes a statement true. Now, so what's everything that makes a statement true? X equals 4 and negative 4. Now, I just want to make sure I tell you, and I've told you this before when we talked about radicals, the square root of 16 is not 4 and negative 4. The square root of 16 is only 4. So where does the plus and minus come from? This is something a little beyond where we're at right now, but I'm just going to tell you the square root of x squared is not x. It's the absolute value of x. And then when we solve the absolute value of x equals 4, we get plus and minus 4. So the point I'm trying to make, the main point I'm trying to make is that you don't have the solution until you find everything that makes the statement true. Okay, having said that, I'm going to get rid of these. I mean, you can write them down, I guess, if you want to, but... Okay, first of all, I'm not going to talk about how to solve an equation, the main idea, how to solve an equation. I'm just going to mention, and I've kind of already said this before, but the first thing you should do is get rid of fractions and decimals. Now, how do you get rid of fractions? You multiply both sides of the equation by the lowest common denominator. So here we have an example. You multiply everything by 30, you get this, and then you finish the problem. How do you get rid of decimals? You multiply both sides of the equation by 10 raised to some power. So we have an example here. We're trying to get rid of 2 decimal places. So we multiply by 10 squared of 100. So we multiply both sides by 100. And when you distribute the 100 to each of those, you get 100x plus 78 equals 30x, and then you finish the problem. Okay? So I'm just going to go through a couple examples. How do you get rid of fractions and decimals? Again, you distribute to terms, not to factors. Okay, so first of all, you have to figure out what are the terms and what are the factors here. Okay, in this problem, the left-hand side is primarily terms. This is the first term. This is the second term. Notice they're separated by a plus and minus. Now, the first term here consists of 2 factors. This being the first factor and this being the second factor. Okay? But still, that's only one term. Now, the second factor consists of 2 terms. So you have the x and the 0.4. So you have 2 terms within 2 factors that are within the 2 terms. I think I should just keep going, and then if you ask me questions, if you want to ask me questions, please do. So what are we going to do here? We're going to have to get rid of the 0.37, the 0.4, and the 0.7. Now, I can't get rid of the 0.37 and the 0.4 at the same time. Why? Because they are different factors. Okay, so what I'm going to get rid of is 2 decimal places. So I'm going to multiply everything by 100. and I multiply each term by 100. And I also multiply both sides. Okay, so what do? I don't give the 100 to the 0.37 and the x plus 0.4. I give it to one or the other. I'm going to give it to the 0.37. Could we give it to the x plus 0.4? Yeah, but I'd only have to multiply by 10 then, because that would only be one decimal place. So I'm trying to get rid of the decimal in the 0.37. So that's 37 times x plus 0.4 plus 70 equals 9. Okay, now I have to get rid of, now we still have the same structure. We've got two terms on the left and then one on the right. Okay, now I have to get rid of the 0.4, so I'm going to multiply everything by 10, every term by 10. Okay, now I don't give the 10 to the 37 and the x plus 0.4. I'm just going to give it to the x plus 0.4. But I have to give it to the x and the 0.4 because those are two terms within that factor. So I have 37 times 10x plus 4 plus 700 equals 90. And then I'd finish off the problem. Okay, which we'll get to. We'll get to finishing off the problem later. Okay, here. I'm just trying to get rid of a denominator, so I'm trying to get rid of the 5. Okay, and that'll get rid of fractions. So that's the only denominator I have to get rid of. So I'm going to multiply both sides by 5. Now here, I only have factors on this side. Okay, I don't have terms. This side is primarily factors. Now, yes, I do have two terms within the second factor, but the point I'm trying to make is it's primarily factors. So you do not give the 5 to both of them. You give it to one or the other. I'm going to give it to the 2/5. The 5's cancel, and you get 2. And then this is 3x plus 7. That stays that. And then this will be 20. And then you would finish the problem off. Okay, here, again, I do not have terms. I have two factors. This is primarily factors. Okay, so what I want to do is get rid of the 2 and the 5. So I'm going to multiply both sides by 10. Now, I don't give the 10 to the 7 and the quantity in parentheses. I give it to one or the other, but not both. I'm going to give it to the quantity in the parentheses. Now, when I give it to the quantity in the parentheses consists of terms. So there's the term here and the term here. So I give the 10 to the half x, and I give the 10 to the 3/5. So I get 7 times 5x plus 6 equals 80, and then I'd finish the problem off. Okay? Here, the only denominator is v. So I'm going to multiply both sides by v, and you get dv equals the v's cancel, and you're left with m. And then you'd finish the problem off, regardless of what you're solving for, which variable. Okay, so the first thing you want to do is get rid of fractions and decimals. But what's the main idea here? In order to know the order, this doesn't tell you how to get rid of them. It tells you the order in which you get rid of things. Do you get rid of added and subtracted terms first? Do you get rid of multiplied and divided terms? What do you get rid of first? What do you get rid of second, et cetera, et cetera? Use PEMDAS backwards. Remember, PEMDAS is when you simplify things that are not equations. SADMAP, which is PEMDAS backwards, is when you solve equations. It's the order in which you move values away from the variable. Okay, so you get rid of added and subtracted terms first, you get rid of multiplied and divided terms second, you get rid of exponents next, and the things in parentheses last. Now, that's the order in which you get rid of them. Excuse me. How do you get rid of them? Well, to get rid of subtraction, you add. To get rid of addition, you subtract, et cetera, et cetera. What do? You always perform the opposite operation from what it is in the problem. Okay, so let's take a look at a fairly simple example. Okay, we have 3x plus 7 equals 5. You can get rid of the 3 first, or you can get rid of the 7 first. You could do either one, but if you get rid of the 3 first, most people are going to make a mistake. Okay, so I suggest you get rid of the 7 first. Right now it's added, So you move it by subtracting. Next thing, you want to get rid of the 3. Right now it's multiplied, so you get rid of it by dividing. Now at this point, before I go any further, there's something I want to mention. PEMDAS is for things that are not equations when you're simplifying. Do you have to do that if you want to get the problem correct? Yes. SADMEP is to solve equations. Do you have to do that? No. It is possible to do it in a different order, but if you use SADMEP, the problem will be easier and you'll make fewer mistakes. So I can't absolutely require it, but you'll probably get it wrong if you don't use it. So again, in this example that I just gone through, you could have gotten rid of the 3 or the 7 first. But, and eventually I'll show you the mistakes you'll make if you don't do what I'm telling you to do. But I'm strongly suggesting you get rid of the 7 first, not the 3. You can get rid of the 3, but you'll probably make a mistake. Okay, one other thing I just want to mention before we start looking at examples is sometimes you need to consider whether you want to distribute something or not. So generally what I tell people is this: always distribute, okay? If there's distribution, do it. Of course, this assumes you've already gotten rid of fractions and decimals. So like up here, like problems numbers 2 and 3, okay? You don't want to distribute first. The first thing you want to do is get rid of fractions and decimals. So what I'm talking about is after you get rid of fractions and decimals. Everything I'm saying from this point forward assumes you're getting rid of fractions and decimals first. Okay, so let's take a look at number 1 here. Should you distribute the 5? Should you distribute the 7? Yes. Why? Because it doesn't create extra x's, the thing you're solving for. Okay, in problem 2, we've got this statement here and we're solving for k. If you distribute the m, will you end up with more k's than you started off with? No. So you should distribute. But take a look at number 3. Same equation, but here we're solving for m. If you distribute the m, will you end up with more m's than you started off with? Yes. You start off with 1, but notice here, once you distribute, you'd have 2. You don't want to do that. You don't want to create more values of the variable, or you don't want to create more variables of the variable that you're solving for. So I would not distribute there. Okay, so let's just take a look at some examples. Okay, so first of all, here, do you want to distribute? Yes, I would. Okay, now I'll show you what you can do if you don't want to distribute, because actually there is a quicker way to do it if you don't distribute. But in general, if you're not sure, distribute. It doesn't cause more x's to occur. So we have negative 3x plus 6x plus 30 equals 6. And then we'll combine the x's, so we get 3x equals negative 24, and x equals negative 8. So what we're saying is negative 8 is everything. It's every single value of x that I could substitute for the variable that'll make the statement true. Okay, now I just want to point out something, though. And if you don't get this, don't worry about it. It's not that important. What we just did is sufficient. Notice there are 2 terms on the left-hand side. And then there's the other side of the equation also. Okay, is there anything that all 3 of those, the 2 terms on the left and then the one on the right, is there anything that all of them have? Yeah, they all have a 3. So what could I do to save myself a little time? Divide everything by 3. Okay, so if I divide the first one by 3, I get negative x. If I divide the second one by 3, I get 2 times x plus 5. And if I divide the other side by 3, I get 2. And then we have negative x. Now I'll distribute. 2x plus 10 equals 2. And then I'll combine the x's, so I get x. I'll move the 10 to the other side, Yeah, I have to admit, it's not like it makes it astronomically easier. But if you're always looking for things like that, there's some problems that will make it a lot easier. Okay, here. Now, what am I going to tell you? There is no such thing as, and I don't even, it's difficult for me to even say this. These words, cross multiplication. Don't ever use it in my presence. Don't ever use that phrase in my presence. It's garbage. It doesn't exist. There's no mathematical operation cross multiplication. Okay? What there is multiplying both sides of the equation to get rid of fractions. So what's the common denominator for the 14 and the 7? It's 14. So we're going to multiply both sides by 14. And on the left, everything cancels to get 11. On the right, you get 2k. And then k equals 11 halves. And I know what you're going to say. But Mr. Leblanc, if I cross multiply, I'll get the same answer. Yeah, that's nice. Go ahead. Cross multiply. It doesn't work. I'm telling you, it doesn't work. Take a look at number 4. Go ahead, cross multiply it. You can't. Why? Because there's no mathematical operation, cross multiplication. You will be training your mind to think improperly. That's all I can tell you. Just don't do it. Okay, let's take a look at number 3. Again, what can I say? I don't want you to use the word cross in my presence unless you want to talk to me about our Lord on the cross. Then come and talk to me about the cross. I'd love to talk to you about it. But when it comes to math, there is no word cross. The word cross doesn't exist, so don't use it in my presence. Having said that, let's take a look at number 3. Number 3, what's the common denominator? It's 15, and this will be 15. So you get the 15's cancel, and you get x plus 6. The 5 and the 15 cancel to get 3 times 4, and you could have gone straight to calling it 12. So that's 12. So we have x plus 6 equals 12, and x equals not 6. X equals 6. Okay? Again, number 4, what you're going to do is multiply by the common denominator, which is 30. So I'm going to multiply every term by 30. Okay, the 2 cancels with the 30 in the first fraction to give us 15. The 5 cancels with the 30 to give us 6 times 3. The 3 cancels with the 30 to give us 10, and 10 times 2 is 20. Then I just, and then it's cake. So I bring the 15x over, and then divide by 5. And at this point, I'll just say something. Do I care whether you give me 18/5 or 3 3/5? Not unless I tell you to, or, if in your homework, if Alex tells you to. But for the most part, it doesn't really make that much difference. I don't really care. Okay, let's take a look at number 5. Again, it depends on what we're looking for. Don't always, find x, okay? Because in this case, we're not looking for x. So what we've got is we're looking for k. So on the left-hand side, is there anything added or subtracted? Yes, there is. There's the z. Get rid of that first, and I'll show you why in a second. So we're going to subtract the z. And now, remember, we're solving for k, so we're going to divide by x. Okay, fine. What if you had divided by the x first, which is possible? This is what most people will get. Divide by x, and they'll give us k plus z equals m over x. Okay? And that's why I tell you not to do that, because that's wrong. Okay, when you divide by x, you don't get that. Okay? What do you get? You can come and talk to me about it if you like, but why should I show you a bad way to do it? So just do what I tell you to do. Well, maybe I'll show you. Okay, I'll show you. If you divide everything by x, notice there are two terms on the left. You have to divide each one by x. So you'd get k plus z over x equals m over x, and then you'd finish the problem. But you know what? If you just follow SADMAP, you don't have to worry about that. Okay, so I'm going to get rid of this thing because I don't really want you doing it that way. I'm just kind of showing it to you. Okay? All right, next. We're solving this for z. Sorry, not for z, for v. What should you do? Get rid of fractions. Okay, now I'm going to show you first. Don't write this down. I'm going to show you first what a big chunk of people will do. Okay, your thought should not be to solve this thing yet. It is to get rid of fractions and decimals, then you can worry about solving it. This is what a lot of people do. People say, oh, if I get rid of the m, I've got the v by itself. So I'll divide both sides by m. Okay, what that gives is d over m equals v, because you got rid of the m, so you're left over with v. And that's why I tell you not to do that, because that's wrong. Okay, you don't get that. What you'd be left with is 1 over v. But most people get that wrong that do it that way. So that's why I'm telling you, the first thing you do, so I hope you didn't write that down because that's incorrect. The first thing you do is multiply both sides of the equation by the lowest common denominator. So you're going to multiply both sides by v. So we have dv, or if we put vd, it doesn't matter, equals m. And then, okay, we have a d, it's multiplied, so we're going to divide. So we have m over d. Fine. Okay, next, number 7. Why do I give you this problem? And you're looking at that, c equals, what is that thing? It doesn't matter what it is. You don't need to know what it is. It's a variable. It's not a number. You need to know that much. But you've never seen a variable that looks like, well, it's a Greek letter. That's okay. It's just a letter. That's all that matters. It's just a variable. Okay, so what do? Well, that weird symbol, whatever it happens to be, is multiplied by v. So what do you do to get rid of it? You divide. And that's it. Okay, it's a Greek letter. Okay, here, number 8. Notice it's the same equation as 6, but we're solving here for m. So what do? You start off the same way. You just don't try and solve it. Just get rid of fractions. So we're going to multiply by v, both sides by v, and you get dv equals m. Now let's solve for m. Oh, we're done. Okay? So one last thing I want you to consider. Remember what you're doing is you're trying to find everything that makes the statement true. Okay, well, sometimes something weird is going to happen, not just in these equations, but in any type of equation. Sometimes something kind of unusual is going to happen. And so you're going to go, well, what do I do now? Well, think about what you're trying to do. What you're trying to do is make a statement true. Find everything that makes a statement true. So let me show you 3 things. Okay, let's distribute the 2 first. So we have 2x plus 10 equals 2x plus 14. Now, let's put all the x's on one side. So we subtract 2x from both sides. And what do you get? 10 equals 14. Or if you moved the 10 over, you got 0 equals 4. It doesn't matter which one. Huh? What happened? The variable went away. Okay, well, we'll come back to it. On this one, number 2, let's take a look at it. We have 2x plus 10 equals 2x plus 10. Let's subtract the 2x's. You get 10 equals 10. Or if you subtracted the 10's also, you got 0 equals 0. Doesn't matter. Either one's fine. Variable went away. Okay, well, what could this mean? Remember, what you're trying to do is make a statement true. Trying to find everything that can be substituted for the variable that make the statement true. Well, what do we know about the statement back in number 1, 10 equals 14? What can make the statement 10 equals 14 true? Well, 10 doesn't equal 14. So it's not true. Okay, well, is there anything I can do to make the statement 10 equals 14 true? No, it's just always false. So what makes this true? Nothing. Now, there's a couple other answers you could put for this, or one other answer. You could also put what's called the empty set. Okay, it just means there's nothing. What you can't put is infinity. What you can't put is 0. I don't know. It's no solution, basically, is it. Okay? All right, let's take a look at this next one. When does 10 equal 10? Well, it always equals 10. Okay, well, what can I do to make it true? Well, you can eat a cheese sandwich and it's still true. It really doesn't matter what you do. 10 equals 10 is just a true statement. So what makes this true? All real numbers. Okay. Not infinity. You know, just all real numbers make it true. It's true. Okay, there's nothing you can do that won't make it true. It's just true. Whereas I'm going to write something down on the bottom here underneath each of these, and I want to point something out. What if you have 10x, which is not this problem, but 10x equals 14? Or what if you have 10x equals 10, which is not these problems? That's why I don't want you to write this down. I just want you to listen. Okay, well, when does 10x equals 14? Well, sometimes it will equal 14 and sometimes it won't. Because if I divide by 10, I get 14 tenths, which of course you should reduce to 7/5. So is 10x equal to 14? Never? No, sometimes it's equal to 14. Okay, sometimes 10x equals 14 is true. It's true when x is 7/5. Whereas up in the problem we had, when does 10 equals 14? It never equals 14. 10 never equals 14. Okay, how about in the second one? The second little example I've written down here at the bottom. 10x equals 10. When is that true? Well, sometimes it's true and sometimes it's not. So if you divide by 10, you get x equals 1. Okay, so when does 10x equals 10? When x is 1. Whereas in the problem number 2, the actual problem we had, when does 10 equals 10? Well, it always equals 10. Okay, so if the variable drops out, you got to think a little bit more. Okay, so I'm going to get rid of these because these are not really the problem. I didn't want you to really write these down. I just kind of wanted to point that out. Okay. All right, how about the last one? Let's distribute the 3. Okay, let's move the 2x over to the other side by subtracting it. Let's move the 15 over to the other side by subtracting it. Gives you 0. So what makes this statement true? Well, the number 0. 0 is not the same as nothing. Okay? 0 is a number. The first problem, where there's no solution, means nothing can make it true. X being 0 on number 3 is something. It's the number 0. That is everything that will make that statement true. Let's say you even had something like this. I'm going to add a fourth one down here. Let's say I'm just going to kind of make this up. 2x plus 15 equals, I don't know, 14x plus 15. And I want you to solve that. Okay, so we bring the 2x over, and we get 12x. We bring the 15 over, and we get 0. What would you do here? You've got to get rid of the 12. You divide by 12, and you still get 0. Okay? What makes that statement true? 0. There is something that makes it true. It's not like it's the first problem where there's no solution. There is something that makes this statement true. By the way, one last comment I want to make about fractions. You should remember that 0 divided by any number, doesn't matter what the number is 0. Whereas any number divided by 0 is undefined. Okay. Now, undefined is not the same as no solution. Undefined is not the same as the empty set. Okay, undefined is something, we just don't know what it is. That doesn't have a definition. So number 1, your only answers can be either no solution or the empty set. Okay, it can't be undefined, it can't be infinity, it's got to be one of those two things. All right? Okay, it's a lot to know there. If you have any questions, please talk to me. I just want to make sure you understand what, it's not enough to know how to do something. You have to know what it is you're doing and when to do it, okay? So what it is you're trying to do is you're trying to find everything, all things that can be substituted for the variable that will make the statement true. So I'm just going to go back to that right now, that the very first thing I set up here. What you're trying to do is find all things that can be substituted for the variable that will make the statement true. Most important thing is that you're making a statement true. I hope that has made your day complete. I hope you're just like really excited now about solving equations, and make sure you understand everything I've told you today is for equations, things that have stuff on both sides of the equal sign. Have a great day.